Okay, this is lab 2-3, sort of part 2 here. I paused it after we've left the live lab that we were doing, and what I've done is I've drawn the schematic up on the board here of all of my connected loads, the 40 watt, the 60 watt, the 100 watt, the 150, and the 200, the light bulbs as they were connected between line 1 and neutral, okay, to our 111 volt source this week, okay, and I've also included the values of current that each of those loads were drawing at the individual points of measurement, okay? So at point A, as was labeled on your diagram, we recorded roughly 0.2, B was roughly 0.4, C was roughly 0.8, D was 1, and E was 1.3, okay? So if we break down how current would flow here, it's best to work backwards because it's easier addition this way. We could say at this point here, we required enough current for this branch and that branch. So the 1 amp plus the 1.3 giving us an F value of 2.3. Okay? 2.3 plus 0.8 will give us 3.1 up here. I hope. Okay? And then 3.1 plus the 0.4 will give us a value of, what is that, 3.1 plus 3.4? 3.5 amps, okay? 3.5 plus the 0.2 giving us roughly 3.7. Now I know initially when I took some readings it was fluctuating between 3.7 and 3.8. I might have initially written down 3.8, or some of these values might have been roughly either 0.35 or 0.36 or 0.34. So it might have rounded up to 0.4 there. The problem with that digital meter that I was using for the ampacity is when we're getting into these finite little currents there, there's some rounding that goes on inside there, okay? So, but overall what we can see is the 3.5 plus the 0.2 will give us 3.7. So if we started with this, 3.7, dropping 0.2, giving us 3.5 there. 3.5, having 0.4 drop off, giving us 3.1 there. 3.1, subtracting that 0.8 at that point, giving us 2.3. 2.3 minus the 1, giving us 1.3 there. Okay? So, and then of course the flip side, all of it would be a mirror image down here in our return path so that ultimately at the end of the day we would have 3.7 amps flowing back into the circuit, okay, or into the source. Because remember, whatever leaves has to come back. All right? Now, some of the other questions that they might ask you would be what happens if we take some loads out, what happens if an open occurred, things like that. We will discuss that in our group chat session tomorrow morning, okay? So for now, that's the end of Lab 2-3, Parallel Circuits.